Okay. Now, just few background information on pointers. So pointers are very useful in C. So if you want to make to have advanced features in C, for example, we've seen in today's session we could, for example, make a function return a value other than we could return an array, for example. So using pointers today, we're going to see how we can do that. There are other things which you can do using a pointer. So a pointer, like we said, is simply a variable which stores the address of another variable. And that is how you can always remember what a pointer is. It is simply a variable which stores, so points at the address of another variable. So using a pointer, you can now get the value of that the value stored at that address as well. So we'll see how to do that. Okay. Just a bit of more background. So why we're talking about addresses here, like we said earlier, whenever you declare a variable, you have a certain memory space that is reserved for that variable, and definitely it would have an address. So a pointer would be able to store that address. So how you can actually access the address of a variable is using the ampersand operator. Remember, we've used that in scanf. You have to be careful about ampersand operator. It's also used for the logical AND, where you use double ampersand. And in the latest video I've sent to you on variables, operators, and expressions, you'll find we also use a single ampersand, as you see here, for the bitwise AND. So when you use it in front of a variable, for example, it's going to mean the address. But when you use it between two variables, it would mean bitwise AND. So it depends on the context. Yeah. But for the particular chapter we're dealing now, the ampersand would mean the address of a variable, and you have been using that in scanf. Now it becomes clear that the scanf function you've been calling to request for a user to input a number or a character or a string, anything, actually means that you were passing the address of that particular variable to the scanf function. This is what it means. Okay. Now let's start with we've seen that today in class, so let's just review that again. So this simple program there is actually declaring two variables. One is var1, which is of type integer, and then an array of characters, which is var2. And then in the next printfs here, we're simply showing you how do you actually print the address of these two variables. Yeah. So the first one is var1. So if you precede var1 by the ampersand, it means you are printing the address of var1, and the format specifier for that is %x, which is for hexadecimal. Okay, so this number which you get there, it means this is the memory address that was reserved for the variable 1. At this point, we're not using any pointers. At this point, we're just displaying the address of the variables. Similarly, if you have an array of characters, so in this case, you will have 10, you can store 10 characters in this array var2. Now, what is the address of an array? It is the address of the first element. We know when you have an array, you would have var2 in the index 0 up to 9. So the address of an array is address of first element. That's what it means. So in this case, you can see how we get the address is by saying address of var2 there, and we are getting BFF5A and so on. So this is the address of the first element of that array. Yep. So this is the basic stuff there. But as we pick up, I've written 4 programs for you, which I will share in a few minutes, and we're going to build in complexity. So at any point in time, it's not clear what we're talking about, make sure you stop and I can explain again. I know this topic can be quite confusing to start off, but if you get used to the pointers and what addresses are and what values stored an address means, it will become clear. Okay. Now this topic there, we have covered it in LAN video already. So I've covered what is hexadecimal and base 16. So we've done that. So I'm not going to go into details there. We've covered that LAN video in MEC 2110. So we know what is the binary system with base 2, octal base 8, and hexadecimal. So you are conversant with that already. Okay. Now let's come to pointers themselves. So like I've said, the pointer is a variable itself. So it means you would need to declare a pointer. Before you can use any variable in C, you know we have to declare it first. So it means a pointer is also a variable. And you can use a pointer now to store the address of another variable, whose value is the address of another variable. Always remember that. So the function of a pointer is to store not its own address, no, it's to store the address of another variable. Okay, so like I've said, a pointer variable needs to be declared just like any other variable in C. And this is a general format for declaring a pointer. So the type would be the types we have already looked at. It can be double, it can be floating point number, it could be a character, it could be an integer number, and so on. So all the various types of characters you've used, this is what this means. And then you will have this asterisk symbol there. Again, be careful. Asterisk may mean many things in C. It can mean multiplication, because this is how we do multiplication. But in this particular context here, the asterisk would mean that you're declaring a pointer. And for our names, there is simply a name you would choose. And of course, you cannot choose a name which is reserved, like a while and if and so on. So you need to choose a variable name which is not part of the reserved keywords. Okay. So some examples of declarations that you have, you can see here. So let's look at the first one. So this is the type of a pointer, and this is the name. IP is the name, and then you proceed by the asterisk. It means here you have declared a pointer of type int. In a few minutes, I'm going to discuss why do we actually need the type for the pointer. I did mention that in class today, so I'm going to elaborate more on that. So this one, the DP there is a pointer of type double. The third one is a pointer of type float, and the fourth one is a pointer of type CH. There's a small typo here. You need to have a semicolon, of course, here, yeah, because all statements need to have a semicolon. It needs to end a semicolon. Yeah. Okay, so you would use, for example, IP. IP, we find that it is of type int. Means you would use the IP to store the address of an integer. You would use DP to store the address of a variable which is double. You will use FP to store the address of a variable which is of floating point, and similarly you use CH to store the address of another variable which is of character type. This is why you have this is preceded by these numbers, but I will explain more why we need these types. Yeah, because in any case, all the values that will be stored here by IP, DP, FP, or CH will all be hexadecimal numbers of this type, similar to this one. Yeah, this type. So why do we need the type? It will become clear in a few minutes. Okay, so in all cases, a pointer is a hexadecimal number that can store the address of a variable. That's the case. In all these cases, it will store the address of a particular variable. Okay, now, so the difference lies in the data type of a variable whose address will be stored by the pointer. So I'm repeating that again. If, for example, you declare a pointer of this type, so IP would store the address of another variable, but that variable needs to be integer itself because that pointer is of that int. So similar for double, float, and character. So once a pointer has been declared, it can now be used to store the address of a given variable by using the ampersand operator. Yeah. So just forget about this one here to retrieve the value stored and so on. So we'll come back to this one. This can be again quite confusing. So forget about this one now. Let's look at the program that we have here, just to illustrate that the declaration of a pointer and storing the address at, of a particular variable in that pointer. Let's look at the first three lines here. So the top one is clear, the int main is fine. We are now declaring a variable of which is calling var, and we are storing 20 at it. Okay, we are storing 20 in the variable var. And then the next line, we are declaring now a pointer. We just said how we declare a pointer. We have a type, and then we have a name, and then we precede the name by the asterisk symbol. This means that IP is now a pointer. It can store the address of another variable. This is what we are doing on this line here. After having declared a variable and storing a value at it, okay, and then declaring a pointer, now we can store the address of var in that pointer. So IP is a pointer. So IP is equal to address of var. So this three lines should make sense now to you. So we are declaring a variable of type int. We are declaring a pointer of type int. So IP can store the address of var because var is of type integer and IP was also of type integer. So you can use IP to store the address of an integer variable, not of a type. It cannot be float, it can't be double, it can't be character, and so on. Okay, so this three lines should make sense to you. Okay, now what if you do something like this now? Look at this printf. We are saying address of var variable. This one we've seen earlier. So if you wanted to print the physical address of var, so you can just call this one with %x and then you use ampersand var. So this is simply this one. Now, next, I'm printing the value which is stored at IP. Yep. So this line here, you can say address stored in IP is you are just using IP directly. If you look at these two syntax pairs, they are different. IP is already a pointer, so you won't put an ampersand in front of it because IP is already a pointer. Whereas var is not a pointer, it is a normal variable. This is why you want to put an ampersand in front of it if you want its address. This is very important to understand. I'll repeat that. var is a normal variable. If you wanted to get its address, you would need to put an ampersand in front of it to get its address. But IP is already a pointer, which is storing the address of var. So you don't need to put an ampersand here because IP is already the address of a variable. That's very important. Okay, forget about this line there now. I'm going to come to that in a few minutes. If you run this piece of code there, this is what you're getting. So for this specific case, we're running this one. This number can change every time, of course, because as your compiler is looking for memory space to store a variable, it depends on what area or what memory space is available. So for a particular execution of the code, this number can be this one, and then the next time you run it, it can change because depending on the availability of memory. Yeah. So we, as expected, the address of the variable and the address stored in the pointer will be the same. Yeah, these two values have to be the same because you have said that. You have said that point this pointer IP to the address of var. So these two lines should give the same address. This is logical. And as we can see here, it is actually the same. But of course, if you do a program like this and run it on your computer, you will not get these values, and you will get some other memory location, but these two needs to be the same. So in a way, this this pointer IP now is able to store the address of var. This is what we've done here. Okay. So again, remember the function of a pointer is to store the address of another variable. Now let's come back to the previous slide where I said let's forget about this part. Now let's come back to it. So till now we have been able to declare a pointer. We have been able to make the pointer store the address of a variable. Now next thing we want to do is how do we get the value, but how do we get the value at the address which the pointer is referencing, is pointing at? Get my point? So in a way, if I come to this program here, we have defined a variable var. We are given a value of 20. We have declared a pointer, and we have made the pointer store the address of var. The question now is, how can I get the value which is stored at the address which IP is pointing at? So it's nothing but 20. But I want to get the value 20 not using var, but using IP. You get my point? So if you wanted to get the value at var, that's very easy. Just use var itself. This is what we've been doing till now. But there's another way you can get the value which is stored at var is using IP, because IP is storing the address of var. So how can we get the value at the address which the pointer is referencing at? For that, we use the this operator. So this is where it might be confusing a bit more now, because you've used asterisk to declare the pointer as follows here. You're using the asterisk again now to get the value which is stored at this memory location which IP is pointing at. Okay, so this is how you get the value which is stored at the memory location which IP is pointing at. If I just make a small annotation there to make this clear, I just want to make this clear. This might be confusing based on previous experience with students. So I'm just going to draw a memory location here. So this is the memory location which is reserved for var. Okay, so this is the memory location for var. It would have a physical address in hexadecimal. Yeah. Now, what you're storing inside that memory location is 20 because you've declared it and then you're saying store 20. So what is at that memory location is 20. And then at some point you are declaring a pointer called IP. So there's another memory location now which is reserved for IP. But what is stored in IP? Because IP is a pointer, it's not a value like 20, it will be the address of var. So this address which is here, the address of this one will be stored in this. Okay, this is what the IP will do, and this is what this line is doing. Okay, now what are we trying to say now? Since you have the address of this variable stored here, I want to use IP to get the value which is stored at the address which is stored here. Is that the point? So how do we get this? Is by preceding IP by the asterisk sign. The asterisk sign here is simply saying, give me the value which is stored at the memory location which IP is pointing at. So if you do that, this is the syntax for it. Yeah. And since IP is of type int, you would use a format specifier %d for it. Everything you find here, as this part there, is simply text. This is text like we've been doing, because this asterisk IP is not a code, it's just a text there which you want to display on the screen. When you put %d now, means you want to fetch the value of an integer. What is that value? Is a value which IP is pointing at. Yeah, it's the value stored at the address which IP is pointing at. So this is how this is called dereferencing. You're getting the value back. Okay. If you run this piece of code now, what you expect to get for this line there would be 20. Yeah, as you can see, as you can see here, when it just clears annotation. Okay, this is what we get. So value of asterisk IP is 20, which was nothing but 20 you had stored initially. This small code there is very important. You have to make sure you understand this code before we move ahead. If there's any doubt, you have to ask now. Yeah, because what we'll do next would build on top of that, and we're going to use pointers to pass to functions, and we're going to use pointers to compare what's a relationship between a pointer and an array and so on. It might become a bit confusing. So I'm giving you a few minutes here. Just make sure you understand this piece of code there and understand all the lines there, what asterisk IP means. So this one is declaration of a pointer, and then you're storing the address of var in that pointer. That's what this line is doing. And then the next two printf is simply cross-checking that the address of var is nothing but IP, because this is what you've done here. This line is actually dereferencing the pointer, means getting the value which is stored at the address which the pointer is pointing at. This is how you get the value. This is called dereferencing. Okay, so I hope it's clear. If not, you can ask question, or as read on that in your handouts and in your lecture notes, it will become clear. Yeah. So, but this is a very important consideration, very important aspect you need to understand on board. Okay. Let's move ahead. If there's any question, you do let me know. Yeah, we've looked at that. Okay. Now, just read what is written in green there. I will come on that when we start covering the programs in Dev C++. So what difference does it make in passing argument to a function by value and by reference? I will explain that in a few minutes in more detail. What does it mean by passing an argument to a function by value? This is what you've been doing till now. Yep. So all the functions you've written till now, you've been passing the argument to a function by value. It means you're giving a value to it. What it means by passing an argument by reference, it means you're giving not a value, but you're giving the address of a variable. So we'll see what difference it makes. So don't worry too much about this answer for the time being. It will become clear afterwards. Okay, so I'm not going to go through this piece of code there. When I send the lecture, the handouts, the lecture notes to you, you can review that, and I'm sure you understand it. So at this point, I would shift to Dev C++. I have written some other functions for you, just to elaborate more on the topic of pointers. But before we do that, any questions till now? So this was the fundamental program. So I hope it's a bit clear. Yeah. So I'm going to shift now to Dev C++. I've written a few codes for you just to consolidate understanding for pointers. Okay, so let's look at this small program there, which I've written, very similar to what we've just looked at. Very similar to what we've just looked at in your lecture notes. So let's look at this one. Okay, so here we are declaring a variable called var1. This line is declaring a variable of type integer. And then you're declaring a pointer here called ptr of type int. And this is how you declare a pointer, again, using the asterisk in front of the variable name. So this pointer is of type int. It can store the address of another variable which has to be integer. Yep, so this is going to be var1. So in this line, we're simply storing the value of 25 at var1. So there's nothing to do with pointer at this point. And then this line here, I'm storing the address of var1 at ptr. This is fully valid code there, because ptr is of type int. It is storing the address of a variable which is int. So this is totally valid. Okay. And this line here, I'm simply printing the address of var1. Yeah, using the ampersand. Again, var1 is a normal variable, it's not a pointer. This is why I need to precede it by the ampersand. Whereas this line is again looking for the address of what is stored in ptr. So this is %x again, but since ptr is already a pointer, I'm just going to use PTR itself. This is very important. Now, the next two printf now, so these two are dealing with addresses. Now, these two are dealing with the values which are stored in var1. That's straightforward. So percentage %d and var1. This is typical printf. This one now is doing the dereferencing, like I just said. So it's trying to get the value stored at the address which PTR is pointing at. So again, it's percentage %d because it's an integer. And then you dereference PTR. So this syntax there is, again, I've said this might be confusing, but in this case here, you are dereferencing the pointer. So in a way, you are getting the value which is stored at the address at which PTR is pointing at. So I'm saying that many times, you should be able to recall what I'm saying. So if I just run this piece of code there to get to, we expect to get 4 outputs. Yeah. So let me just compile and run. So let me just show you the screen so there's no error, and then just run it. Let me share the output screen with you in a few minutes, and so you can see output. Okay, so this is what I'm getting. So I don't know if you can see the program in the background as well as I'm moving the output screen. So the address of our one, so this was this code there is 62FE44. So this is the memory which is reserved on my computer for the variable one. It might be different when you run it on your laptop. Then the value which is stored in PTR is nothing but 62FE44 because we have made PTR stores address of our one. So these two have to be the same address state. The next two printfs now are getting the values. So the value of our one was 25 as assigned. So this is fine. And as expected, the value which you would get when you dereference PTR should be 25 itself because PTR is storing the address of our one, which is nothing storing. So for one is having a value of 25. So when you dereference the pointer, you should get the 25 back. Okay. So I hope we've taken two examples of declaring the pointer, making a pointer store an address, and dereferencing the pointer using asterisk. So you should be comfortable with that now. Okay. So I'm moving back to the dev C++ now. Okay, so I'm going to consider now another program. Yep. So it is the program which we did today in the practical class where we're doing sorting. Okay. So remember what we said when we were discussing the sorting. We've said that we can't actually return the sorted array back to main because a function in C cannot return an array, cannot return more than one value. Okay. So one solution for that was to make the function return a pointer. So this is what we're going to do now. Forget about this one for time being. I'm just commenting it so that you don't make confusion with that. Yep. And so let's look at this one now. So we know this one is actually function declaration because this is, I can say it is above main. So what this function is doing, this is called sort AST. It is returning a pointer and it's taking an integer array and also an integer. So that in there will be the size of the array. This one will be the array which is not sorted. And then what we are returning now from this function is a pointer. Yep. So let's see how can we make how can we actually return the sorted array back to main using a pointer. Okay. So this is typical what we've done in class today. So int x, so we are declaring here, declaring and defining the array. Okay. And at this point, we are printing the content of the unsorted array. So this is familiar with you. We've done that today, this part there. So we are printing the content of the unsorted array using the for loop. Yep. And then at this point, I'm calling this function there, sort ASC. Yeah, sort ASC will be very familiar to you because we've done that in class today. In a few minutes, we're going to look at its content. So what is happening here? We are calling sort ASC with the unsorted array X, okay, and we are passing size 10 to it because this is the size of your array. Now we expect sort ASC to return a pointer of type integer. As you can see, the return type is int. And what I've done here in this main program, I've declared a pointer called PTR. Yeah, PTR. This is of type int, and I'm storing this pointer which is returned by sort ASC. It is being stored in PTR. Yeah, because the function is returning a pointer of type int. You need to of course have a pointer of type int to store the result. That is what's stored at PTR. forget for the time being what I've written here. Yeah, for the time being, just forget what we have written here. Let's come to the function itself, how it is working. Okay, so this is familiar to you. We have int y. Yeah, we have int y. So this is if you see how you call the function. So x will pass into y, like we've done today in class, and 10 to n. And then this is very familiar to you. This is how sorting was done, remember? So you would do some swapping depending on the content, on the values of the yi and the yj. So this is familiar to you. Now, important point here is when you have done the sorting, you're returning y. So what was y? Y was actually the array. Yeah, the array was y. So when you return y, the name y for an array is nothing but a pointer itself. This might be maybe confusing for time being. I will explain that in more detail. Okay, so remember that the return type of the function was of type integer pointer. Yeah, so when you return y there, it's actually the pointer you're returning. Yeah, so this might be a bit confusing. To explain that in more detail, I will have to consider this third program, and then we'll come back to this one. Okay, so the doubt here is how come y is an array? You're returning y, and the y itself, so the array name is a pointer. Yep, so that's what the doubt is. So let's clarify that by looking at this program here. Okay, so this program here will clarify the difference or the relationship, if you want, between a pointer and an array. This is what you want to clarify. Okay, so in this program here, which doesn't have anything to do with function, it is simply having some variables here for us to illustrate the relationship between a pointer and a function. So let's look at this line there. We are defining I as a normal integer. That's clear. We are declaring PTR, which is a pointer of that int. It's also okay. My array is simply an array of integers, and we are already defining it as 1, 23, 17, 4, minus 5, 100. So we have 6 elements in your array. Okay, so this thing here is pretty standard. Now, just look at this line. I'm going to remove this one and put this one to start off. Yeah, to start off, I'm going to do that first, and then we understand the other one as well. So what I'm doing at this point, since we said the task of a pointer is to store the address of another variable, so that's what I'm doing here. I'm storing the address of the first element of the array. So what I'm highlighting here is the first element of the array, is it not? So my array 0 is the first element of the array, and its address is being stored in PTR. Okay, that's what this line is doing. So basically, I'm storing the address of the array in the pointer. And what is the address of an array? It is simply the address of the first element. So the first element starts at 0. Okay. Now, the following 2 lines here is simply, if you've looked at the latest video I've sent, you have a section on the size of function. The size of function is a function which allows you to find out how many bytes are actually stored on your specific machine for different types. So integer, character, double float, and so on. If you use a size of function, you can find out how many bytes are stored for a specific variable type. So when I'm running this line here, I'm saying number of bytes reserved for one integer. So put %d there. And what I want to display is the number of bytes which is used to represent my array 0. So this is just one element of your array. Yep. So when you say size of my array here, basically you're asking how many bytes are reserved for one integer, because my array was of that. So when you run that, you might get 2, you might get 4, you might get 8, depending on your machine. On my machine, it's actually 4. So when I run that in a few minutes, you will see that. Now, next thing which we do is we want to print the start address of the array. So this is, I just want to illustrate something here very important. Typically, I will need to do it that way. I want to show the address of the first element. Yep. I'm going to put a second printf. Exactly the same. Just to clarify the doubt we had initially, but now I'm just going to put the array name. Yeah. So let's look at the difference between these two lines there. Okay, the first one, this printf is giving the number of bytes. That's okay. Now, this one is simply giving me the address of the first element of the array. So this is the first element, my array 0. And when you put ampersand in front of it, you get the address. This we have seen earlier. Now, this line is not clear yet, but when you run the code, you will see. I'm saying start address of array. I'm just using my array, which is the name of the array, without any square brackets, nothing. I'm just saying what actually I get here. Okay, I'm going to run this piece of code here. Let's forget what comes afterwards here. This is, I'll come back to that. Let's see what these values give to me. Let's forget what comes afterwards. I'm calling this one sum ref, to say sum reference. In this case, I'm not passing values, I'm passing pointers. Yep. So this is what is shown here. So sum ref, the function of sum ref, the objective of this function is again to sum the two numbers. So this is why the return type is still int. Okay, but I'm not going to pass the values themselves now. I'm going to pass addresses. So how we do that? This one we've done already. Let's look at this one now. Yes. So when I'm calling sum ref now, I'm not passing A and B itself. I'm passing the address of A and the address of B. We know that when we have an address of a given variable, I can very easily get the value by dereferencing a pointer. Okay. So when I call sum ref, I'm passing the address of A and address of B. Let's see how sum ref looks like now. So this is sum ref now. This is what you said. We are not having now, we are not having values, we're having pointers. Remember, this is how we declare the function. So this is why you have int asterisk x now. So x now is a pointer of that int, and y is a pointer. You can put a space here, or you can leave a space, doesn't matter. Yeah. So y is again a pointer of that int. So if you just go back to the function call, we've passed the address of A, address of B. So address of A will be stored now in pointer x, and address of B is going to be stored in pointer y. Yeah. Okay, so same thing now. What are we going to do now? We're going to check the addresses of A and B, and we're going to check the addresses of x and y. We don't put ampersand here because x and y are already pointers. As expected, because you're passing the addresses of A to x, you expect the two to be the same. Okay, and of course, if you want to return now the sum, this line there, I hope it's a bit clear to you now. If I want to return a sum, when we are dealing with values, you want x plus y directly. But now, if you want to sum the two values, you would have to dereference the pointer to get the value, dereference the pointer to get the value, and then sum the two values. Because ultimately, you want to return the sum of the values from the function, not the sum of the pointers of the addresses. Yeah. So this is what it's doing. If you wanted, if this is a bit confusing, you can do something like this: int result, and then you can say here result is equal to dereference x. So this is what you get when you dereference x, means get the value which is stored at the memory location at which x is pointing at. We've discussed that. Similarly, dereference y, you add the two, and then you can say return rest. If that's confusing, you can read this one. Okay, so let me run this one now just to illustrate what happens in terms of memory location. Okay, this is what you're interested in. We've observed earlier that when we pass by value, you have different addresses. This is what we've concluded. Now, this is again the initial part there where you have the call by value. We've observed earlier that you have different addresses. Okay, now look at the addresses which you have for the addresses inside your function. It is 62FE48, which was the address of A, 62FE44, which was the address of B. So when you call by reference now, you're having the same addresses in your function. That is very important. It means you are operating on the same variable you are having in your main. That's a very powerful concept. If you are using pointers, it means you are able to operate on the same variable you had in your main. So x and y are nothing but pointers to A and B, because you've passed the address of A into x, the address of B into y. When you do that summation of the dereference value of x and y, you're actually operating directly on A and B. This is very powerful. If you have the addresses of A and B, you can even overwrite or change the value of A and B in your function, but A and B is fine in your main. This is how dangerous pointers can be, and this is how powerful pointers can be. if you've got the address of A and B inside your function, you can change the value of that. You can change the value stored at this pointer, and you're actually changing the value of A and B, which you can't do when you pass by value. I hope it's clear. So you can see clearly here when you are dealing with pointers, when you pass arguments to a function by reference, means by using pointers, you're actually having the same address. This is very important. Okay. Now, next two things I want to discuss before we end. I have two more functions I've written there. Look at this one now. I'm calling it void pow2. So this is the name of the function I'm creating. It has two inputs, so it's not returning anything. Okay, it has two inputs. It is taking an integer and it is taking also an integer as a pointer. Let's see what I want to do in this code here. So this is what I'm doing in pow2. I'm passing A. So A had a value of 3. And I'm passing now the address of SQ. So SQ was an integer. SQ was an integer variable I've declared. So in that function there, I'm passing A and I'm passing the address of SQ. Okay, let's see what happens. Now let's go to that function pow2. Pow2 is very simple here. So when I pass a value of A, it's going into Y. And now when I'm passing the address of SQ, it's going into PTR. Okay, what I'm doing now, I'm storing the value at PTR because this is what's dereferencing. I'm storing the square of Y at PTR. This function is not returning any values void, but since you've passed the address of SQ in PTR, just now I've mentioned about this, you can actually write the square of the number at that memory location which you have for SQ. So when you go back to your main now, since you've passed the address of SQ, you're able to get a square that you have computed in your function, in your main, and you can display. That's a very powerful concept again. So let me repeat what we've done again. In that function there, I'm passing A, that's fine, but I'm passing another argument at which I want to store the result. This is why pow2 has no return type, it is void. So since I'm passing the address now of that variable SQ through PTR, yeah, PTR, and I'm storing a square at that memory location. Now PTR is nothing but the address of SQ. So when I go back to my main now, when I get the value of SQ, I would get the value which was stored at PTR in the function. Very powerful concept again. So this allows me to do something more intelligent now. Look at this function now. In that function SQ, I want to do two things. I want to calculate the square of A and the cube of A. Unfortunately, I can't return two values from a function because a function in C is limited by only having one return. But if I pass SQ and CUB like this as arguments, if I go to SQ cube now, so this is your A, I'm having two pointers. I can very well store this 60 square at PTR1, the cube at PTR2, and since PTR1 is nothing but the address of SQ and PTR2 is the address of cube, when I go back to my main now, I'm going to get the square and the cube, even if I did not return from the main, from the function. This is a very powerful concept. So this is how you can make a function calculate more than one value for you, and you can overcome the limitation of a function in C not being able to return more than one value. So you can see the declaration of SQ cube is void. It's not returning anything, but still you're able to make it calculate as many number of values you want by passing pointers to it. Simply because the pointer you're passing is having an address, and the same address is found in your main and in your function. This is a very powerful